Welcome to this A-level D1 lesson on algorithms. Now, first of all, I'm just going to discuss what an algorithm actually is. And really, an algorithm is a very clear, unambiguous set of instructions that will lead us to the solution of a particular problem. Now, it could literally just be lots of written instructions, or we could put our algorithm into a flowchart, which is what we've got here. Now, there are a few conventions with flowcharts. What you'll notice is you sometimes get these diamond type shapes here, and that's when you've always got a yes or no answer. When you've just got a rectangle like this, it means you've just got to do something, which you then input into your trace table. So let's get this started. It tells us to start with A being 84, so we just put that in there. Okay, so we've inputted A. Next, let's follow the arrows down, and we've got to let B be the first number on list P, which is 2. So we put that in there, and then going down further, let C be A divided by B. Okay, so that will mean that C is 42. So we're there. Now we've got that question, is C an integer? Well, yes, 42 is an integer, so we answer yes. And then we need to go down here, because that's where the yes is, and we output B. So if this was a computer program, 2 would be outputted onto your screen. And we're just going to make a note of that there, output B, which is currently 2. Now another question, is A equal to B? Well, no, because 84 doesn't equal 2, so we're going to get sent round this way and actually just make a note of no there. Now it's getting us to change what A is, and we've got this rather odd equation which would be somewhat unacceptable were this to be pure maths, but we're going to let A equal what C is. Now C, you can see, is currently 42, so we're going to let A equal that. So A is now 42, and let's just follow this all the way around, and it tells us to let B equal the first number in list P. Now, for whatever reason, I'm wanting to put 3 here. I'm wanting to move through the list, but it's not asking us to do that. You've got to let B be the first number in the list again, which is still 2. Next, let C equal A divided by B. So C will now be 21. Now, is C an integer? Well, yes, 21 is an integer. So now we're here, so we're going to output B again. So for the second time, we've got a 2. And is A equal to B? Well, no, it still isn't, because 42 does not equal 2, so no. So we're here again. We seem to be just repeating ourselves. Let A equal C. Now C has changed. C is currently 21. So now A is going to be 21. So follow it round. And again, let B be the first number in list P. So it's still 2. And then let C equal A divided by B, which is not actually an integer. You can see you're going to get 21 over 2. So that's not an integer, clearly. So let's see what it wants us to do. So it's not an integer, which means we go down here for the first time. We've not been here yet on our flowchart. And here it's asking us to increase B to the next integer. So just start a new line. You don't have to fill in all of these. You don't even have to fill in that if you don't want. Just start a new line and increase b to 3. Alright, let's just follow this round. So here we go. Now let's C equal a divided by b. Now a is still 21, that's the last recorded a, and b is 3. So now C is going to be 7. So where here we're going into this box, is C an integer? Well, yes, it is. So now because it was yes, we go to here. So now our output B is currently 3. So we put a 3 there. Does A equal B? Well, A is currently 21, and no, 21 doesn't equal 3, so we go to here again. So we just put no there. And let A equal C. So C is currently 7. So now A is going to be 7. And we go all the way round to here. Now let B be that first number again. And we're now here. Let C be A divided by B. So that's going to be 7 halves. Clearly that's not an integer. So where are we? We're here again. So we get sent round there, and we need to increase B to the next number in the list, which is 5. So we do that there, and follow it round again, and it has another go at trying to get an integer. C is A divided by B. Well, currently A is 7, B is 5, so we get 7/5 here, and that's still not an integer. So again, it sends us round here again. Apologies. Increase B once more. Well, that means B now goes to 7. So C is A divided by B. So we get 1. Now, is that an integer? Well, yes. So let's follow it down here. So it tells us to output B. Well, B is currently 7. So there we go. And then it asks, does A equal B? Well, actually, on this occasion, it does. 7 does equal 7. So we say yes, and then we follow it, and it tells you to stop. The algorithm has ended. So we put in 84, and out we got a 2, a 2, a 3, and a 7. So let's just put that here. What we actually got: a 2, 2, a 3, and a 7. And this is a very typical question now. What does the algorithm achieve? Well, if you've not guessed it already, 84 actually equals 2 times 2 times 3 times 7. It's broken 84 down into its prime factors. So the algorithm, apologies, here's something I prepared earlier. The algorithm achieves the prime factor decomposition of the input. Okay, so it's very typical of them to ask actually what it achieves at the end. Now, I hope you followed that, and I hope you are confident now to try some of your own. I've got one here for you. What you might want to do now is just pause the video. So I'm about to reveal the solution to this. So give that a go. And there's another question I've got prepared here as well. So if you'd like to pause the video there. And there's a solution, a Fibonacci sequence there. Most of these are past paper questions, by the way, quite old questions, sort of from 2003, 2004, that sort of era. Here we've got another question. And the answer there. Okay, I hope you enjoyed that lesson.